Today I'm going to be talking to you about the enrollment patterns and predictions for Fall 20. This information is based on the data extracted from the MOAR report, and the predictions will be based on curricular changes and a holistic view of the FTES generated at Butte College. On each slide I've included art from Black artists. My intention is to remind us, myself included, of the voices that aren't in the room. I will take a moment at the beginning of each slide to pause, look at that art, and keep in mind who's not here and who we have to consider when we're making big structural decisions. The presentation will be centered around this slide. I'm going to zoom in at different points and highlight different aspects, but right now I'd like to give you an overview of the structure, what each of those sectors represent, and why I've made this particular breakout and how it can help us understand the flow of FTES from different sectors of our college. The top left collection of graphs are the 3-year trends of FTES broken out by CSU GE area. If you focus at the top left, A1 oral communication, you'll see the scale on the left, which goes from 0 to 300. That is in FTES. Along the X value, those are fall, spring, fall, spring, fall, spring. So there's 6 dots representing 3 years. The top layer is oral and written communication and critical thinking. The middle blue layer is physical sciences, life sciences, lab, and area B4, which is mathematics and quantitative reasoning. And on the bottom, you have area C1, C2, arts, humanities. The green is social sciences, and the pink is lifelong learning. You'll notice the green plot is taller than the other ones. That's because that scale goes all the way up to 600, and we'll talk about why that is. Students can take these courses for a variety of reasons. They can take them for GE, they can take them as part of a program, and they can take them as electives. On the upper right quadrant is all the courses that do not have an entry in the CSU GE area in the MOAR. So these are courses that are for nursing or RT, courses that have disciplines that aren't typically in the GE categories. It also includes courses that are transfer prep, courses that are local area GE courses like kinesiology, courses that are community service like our community partners in education, which used to be special education courses. So taken together, these two groups, the left quadrant and the right quadrant, represent all the courses that we offer at Butte College. So this is non-overlapping set and is complete. There are two representations of the same data on this chart. The highlighted one looks just like the ones broken out by GE area. The scale is slightly different. You'll notice where the 300 is, it's not exactly where the 300 was for the GE areas, but I had to squish it down to make it fit. The solid jagged line is the total FTES from all the non-GE courses. The dotted line is the fit. In the GE areas, we have a dotted line fit as well, and the equation on the top is the equation of that line. What we're paying attention to in that equation is the number that goes in front of the X. If it is negative, it is sloping down, meaning the GE decreases, the FTES decreases, for this case, 180 FTES per semester. So that representation is there. More detailed view of the same data is shown highlighted there. You can imagine each of those disciplines as blankets, and the thickness of the blanket is proportional to the FTES generated in those classes. And what we're showing here is the stacking of those blankets, with each color representing, which each thickness of the band representing the amount of FTES. The six different periods are the same: fall, spring, fall, spring, fall, spring. And so this just breaks out the diagram on the left. At the bottom left corner, you see a picture of the GE structure. There are three columns. The column on the left is the Butte College local GE pattern. The column in the middle is the CSU GE pattern. And the column on the right is the IGETC UC GE pattern. These share a lot of similarities. We're using the CSU GE pattern because the large majority of our students who transfer into the CSU system. Each of the boxes in this diagram represent a class to be taken, and this is a holistic vision of our entire GE demand for Butte College. In the bottom right-hand corner, you'll see a representation of the efficiency. Each individual column is a semester. The color coding are intended to show that the same semesters across the different column groupings. The column groupings are sorted by GE area, just at the top left quadrant, and the grouping on the right-hand side is the non-GE areas per semester. This is just one aspect of the cost efficiencies required to deliver this FTES. It does not represent any incoming funds or outgoing funds that are not captured in FTES or FTEF. When we get to the end, we will zoom in on the various aspects of that and unpack some issues that we might face in terms of meeting student demand efficiently in the future. What I'd like to do now is demonstrate how the GE structure dominates the demand that we see at our college. What I'm going to do is I'm going to bring in these different squares. Remember, each one of these squares represents a class that must be taken, and each square is 3 units. I'm going to push this button. These squares are going to move up to the FTES diagrams, and you're going to see them scaled against the composition course. In 3, 2, 1, boom. With these boxes stacked against the observed demand, you can see the correlation between the two. This is clear evidence that the GE structure dominates our demand. This is why the green area has 3 boxes. There are 3 courses required, and that's why that scale had to be different. The combination of the 2 orange squares is commensurate with the GE demand. The pink square, the blue squares, the yellow squares, there are slight differences, but you can see for the most part that our demand is determined by what is required for GE. What determines demand on the right side is much more complicated, but for the left side, we can at least look to the GE structure for mental math or any sort of issues that we have to deal with when we're thinking about what to put in the schedule. So the rest of this talk is going to be zooming in on each of these areas and explaining in more detail what they mean and what they might mean for our future. As we focus on the FTES broken out by GE area, I'm going to bring in the previous 3-year trend visualizations. These are like the band diagrams shown in the previous slide and broken out by GE area. So at the top you'll see the composition, in the middle you'll see area B, and I broke it out the area C and D and E below. 3-year trends in A1 and A3 have been relatively stable. A2 has been all over the map, but that's mostly because of AB 705. They've shown shallow declines, but there's a reason to expect that these declines are flattening out. I think enrollments will stay the same or increase slightly, not counting the return students from the COVID drops that occurred this semester, and I will discuss that toward the end when we get to the efficiency discussion. In the B area, we've had steady increases in B1 and over time B2. The B3 area you can ignore. These are the classes that are only labs. Most of the labs are woven in to the normal classes in B1 and B2. And B4 has demonstrated significant increases, and the reason for that is AB 705 related. High fill rates in majors courses for chemistry and biology suggests that we have to keep on top of the enrollments in those courses to ensure that we can meet demand of all students who wish to have programs in STEM. And the demand for the sectors C, D, and E GE areas has continued a decreasing pattern seen in the previous 3-year trends. C1 has remained flat or increasing. The arts, humanities, and Area D have shown the same types of decreases seen in Area A1 and A3, non-AB 705 related decreases. And Area E is also decreasing at a slightly higher rate than the other areas. While these trends continue from the previous 3-year trends, there is reason to believe that this downward trend is stopping or at least slowing down. We're going to see later the COVID drops had a significant impact on our enrollments. What I'm going to do right now is highlight what happened before COVID. These points are all the semester before COVID, and without fail, they demonstrate an elevated value over what would have been predicted by previous trends. I think this is a pretty solid indicator that our enrollment numbers would have started to look up were it not for the COVID pandemic. As far as signals go in this very noisy environment, this is as good an indicator as you could find that our enrollment declines are starting to turn around based on what our enrollment strategies are out into the community, based on other factors that we have no control over. Whatever is going on, it seems like enrollments would be on the way up were it not for the COVID pandemic. On the next slide, we're going to focus on AB 705 related issues. We're going to focus on the impact of chemistry curricular changes on the B1 physical science area and supply side impacts on B2 on our narrative for the demand in these different areas. AB 705 has shifted the FTES from the transfer prep into transfer level English and math. You can see on the right-hand band diagram, the blue band and the yellow band. The blue one is math, the yellow band is reading and English. You can see over time those narrowing as you go from left to right. That narrowing, you can imagine, is kind of being squeezed into the transfer level. So if you follow the circle that's on the right side that's circling the yellow, you can see it. Watch that FTES flow into English, and you can watch the blue squeeze into the mathematics and quantitative reasoning transfer level. That's mostly Math 124 being converted into students taking Math 18. Global impacts of AB 705 transition in these areas will await the details about how many students go into each composition course, for example. English 3 has significantly more FTES than English 2. So based on how that balances out in the long run will determine what our equilibrium space is for area A2. Similarly, in the math area, if students, the long-term behavior of how students interact with that curriculum will be determinative of how FTS equilibrates in the general competencies of math and English. What we haven't also considered is the impacts on completion. The whole purpose of AB 705 was to get people into transfer level under the assumption that if they got into the transfer level, they'd be more likely to complete. And we're going to see if that's what actually happens in the long run. An indicator of the AB 705 plan working will be a change in the relative FTES in the composition and math courses to the other areas of the college. So relatively speaking, the other areas, say, for example, C, D, and E, should increase relative to the previous composition scores. If AB 705 is actually increasing completions, we should see it in the overall distribution of FTES and how they distribute out through the GE patterns. And most importantly, the impact of AB 705 should be to reduce the equity gaps that we find in our completions. If AB 705 is not reducing our equity gaps, we need to investigate other methods for making that important mission happen. To highlight another significant curricular change that will impact FTES. If you look at the circles I'm going to add here, from the black Chem 110, you'll see that shrinking on the right-hand side, a little blue circle there, and the increase in FTES in the Chem transferable side. The chemistry department has worked with the curriculum committee to convert their Chem 110 course, which is a prep course and also stood as a prerequisite for a number of different biology programs which fed into allied health, into a transferable course, which is now called Chem 11. Chem 11 and Chem 110 have the same number of units, but what has happened is biology has removed the Chem 110 as a prerequisite and replaced it with Chem 51, which has 30% more FTES per student than Chem 110. So what we're going to see is an increase overall in the FTS of that course as we start serving the same number of students and those enrollments equilibrate. And for the life sciences, we know that we had to remove sections because there was a faculty family issue. So in that particular little dump there, shown in the life sciences, there was a supply side removal, which does not reflect student demand. It's very difficult to interpret these diagrams in terms of demand if the demand is reaching capacity for what we are supplying. And this we see a lot in the STEM areas because we don't have a lot of flexibility in part-time assignments in those sections because part-timers are hard to find. So all in all, it seems like we have a pretty good picture for all the anomalies that might be seen in this particular diagram. What we'd like to do next is transition our focus to just the non-GE section. We're going to focus on various aspects of this diagram to illustrate the impacts of COVID, the impacts of the campfire, and weave these together to construct a picture of what the enrollment patterns would be without those disasters and where we might see ourselves going into the future. First, we're going to focus on the community partners and education contributions to our FTES. This used to be special education, and I've put in healthy aging and living and occupational life skills. You can see on the top part where there's gray and the lines are separated out, you can see the switch that happened from special education on the left to community partners and education on the right. These are all externally held centers. During the campfire, we lost 7 of these centers. There was a huge decrease in the FTES in these sections. Same thing happened with COVID. These are significant contributions to our overall total FTES, and campfire and COVID has decimated these contributions. This is a huge component of the downward trend seen in the non-GE courses. Next, we turn our attention to the COVID semester. You can see in this diagram something significant happened during the COVID semester, and there's a huge decrease in expected FTES from previous trends. Systematic campus-wide COVID signal, if you consider all the non-GE contributions, not including math, English, and the CPE contribution, the aggregate COVID-related loss is estimated around 15% for the spring semester from the total FTES. Here, that change was about 30%, but the non-GE courses account for about half of the total FTES we offer on the campus. If you isolate the impacts and just focus on the part of the graph that doesn't have the CPE, doesn't have the AB705 decreases, and doesn't have the loss from the COVID semester, you'll see this little rectangle right here has a very distinctive signal that is either increasing or at least flat in FTES. So the overall signal from the non-GE courses, not including the dastardly things that have happened to us in the last couple years, exhibits promise and at least stability in this sector of our offerings. So if you look at the overall trends highlighted in this rectangle, you'll recognize that the vast majority of the negative contribution from those trends is predominantly COVID and campfire related. It's important to realize that if we're going to be using any trends to try to predict the future. To summarize our enrollment observations, before COVID, signs were pointing up. GE area declines seem to be flattening and potentially on the rise. This is good for our assessment of the future of our GE side courses. In the non-GE sector, enrollments have been increasing slowly over 4 years. But these courses took a huge one semester hit, about 15% for the total semester. The percent COVID hit for GE courses was significantly smaller relative to non-GE courses, less than 10%. That's significant, but it's interesting that there's a difference between those two impacts. AB705 over the last 3 years has an estimated negative 7% decline in our enrollments. We are almost at the end of that. I predict by the end of spring 21, all of our issues with readjusting FTES around AB 705 related courses will be equilibrated. And importantly, one thing that's very important to point out is that these trend lines that we see are not illustrative of our future. It may be more important now than ever to highlight the fact that trend lines are not illustrative of our future.
And if you don't believe me, Justin Wolfers is a very famous economist, and he's expressing the reality of these unprecedented events and what they do to data. So even macroeconomists are having problems here. Now that we have a holistic sense of our demand for courses at this college, we can take a look at issues involving efficiency. I'd like you to take a look at these two band diagrams. The one on the left is FTES, and the one on the right is FTEF, and answer the two quiz questions that I have for these so we can learn how to interpret these diagrams.
You may or may not have been able to take this quiz. But in any event, let's move on and zoom in on some issues of efficiency. Efficiencies at this level are about essentially two things: class size, also known as section caps or pedagogical caps, and fill fraction, also known as fill rate. Class sizes are decreasing in aggregate because online courses have a standard of 35 student cap or section cap, and are increasingly replacing courses with higher section caps, sometimes going from 50 to 35. May or may not cause demand problems. If the fill fractions were high in these courses, then changing this ped cap to 35 will be a problem. We will have to either create more supply by hiring more faculty. If that's not available, we need to investigate some strategies for expanding within the classes, maybe through union negotiations, or there may be counseling strategies that can redirect students from those courses that are overloaded due to ped cap changes into other areas of our college so that the students can most efficiently get their requirements met and we can get them out of here as fast as possible. Another impact that's going to be seen is that online courses are less constrained by schedule, which has a net effect of increasing the fill fraction part of the balance, since students fill up online sections faster. So if the demand is determined by the CSU GE patterns, we're not creating demand by adding online sections. We're just shifting the demand from possibly face-to-face into the online section, and we have to make sure that we curate the balance between those things and mindfully make decisions. Let's focus in on the impacts of COVID on our efficiencies.
This diagram is an attempt to capture a bunch of information about fill fraction, the spread of the fill fraction, and the estimated COVID drops that have occurred. If you look along the bottom, you'll see the GE areas.
Black dots, the black dots represent the average fill fraction from fall 17 to fall 19. So I did not include COVID. This is the average fill fraction. That means 80%, for example, means that the class typically fills to 80% of the pedagogical cap or the class cap. The pink bar on the top is an estimate of the spread. For the mathematicians in the house, I merely took the standard deviation of 5 numbers, which is not typically advised. I could have equally shown the range. There is no significant difference between those two strategies. So that gives you an estimate of the spread of the fill fractions that occurred during that time frame. The red bars hanging down is how much below the typical fill rate, fill fraction, the COVID semester ended with. So I made a calculation, like a predicted amount of fill rate, and then subtracted the actual fill rate observed from the predicted amount to get those values. And they have the same scale. So let's look at A1. So look all the way to the left. A1, sector A1 has a typical fill rate of 90% with a fairly low spread. So variance in those fill rates are fairly low. Of the 90%, the final fill rate for the COVID semester was about 17.5 percentage points less than 90. So typical would be 90, and what was observed was about 73%. So you get an idea how that works. The white crosses I'm going to explain in a second. What I'm going to do is make little red bars, and then I'm going to take those and scale them and put them on the diagrams to the right. So we can get an estimate of how those dots would be moved around if COVID didn't happen. So we're going to take those little bars and we're going to scale them and move them over onto that diagram. Now just take a minute and look. So each of those bars tells you how much that final point would be raised. And then you can think about how raising that final point would change the slopes of all of those dotted lines. For the most part, you can see that it would turn negative to positive.
Turning our attention back to the graph, looking at the white crosses indicate that we're going to have a bottleneck of students getting into the composition and math classes if we assume that those students that dropped during the COVID semester are going to come back. We just have to be aware of this potential bottleneck when planning for future semesters. All told, I think we have a satisfying picture of what has happened in our enrollments in the last 3 years. It makes sense, and I think it guides us in the decisions that we have to make about course offerings on this campus. Thank you for your time and attention, and please contact me if you have any questions about the analysis, the provenance of the data, or any other issues discussed